Good morning, good afternoon, good evening, everyone. Very pleased to be here with you today to talk about membrane tank solution for pure car and truck carriers. My name is Jonathan Licher, and I am product line developer in commercial division of GTT, in charge of developing our solutions for LNG fuel ships and making sure to offer the most competitive designs to our partners. I would like to introduce as well my colleague Jean-Guillaume Merzeau.
Hello, ladies and gentlemen. Thank you all for attending our webinar. I am Jean-Guillaume Merzeau, naval architect, working in the basic design department of GTT head office, and I am in charge of PCTC technical solution development. For several years, we have been working on the PCTC segment, and we are very glad to present today our membrane tank solution for LNG fuel PCTC.
We also want to hear from you. So we have arranged 25 minutes for a Q&A and a poll session in the second part of this webinar. There will be a dedicated chat for Q&A, so do not hesitate to write down your questions at any time, and we will answer them during the second part. For your information, this webinar is being recorded, and the recording will be available on demand. For those of you just joining us, welcome. We are now moving to today's agenda. Firstly, we will start with a quick introduction of GTT Group, its technologies, and an overview of GTT recent success regarding LNG fuel ships. Then we'll jump to the PCTC market. Afterwards, my colleague Jean-Guillaume will present the ship design, explain the specific developments we made to make PCTC design future-proof, and we'll conclude this part with an overview of possible industrial schemes. Finally, you will hear me again for the conclusion. GTT is a French engineering company and a key player in the field of liquefied natural gas, LNG, and all types of liquefied gas. It offers established, secure, and efficient technologies for containment of liquefied gas at low or cryogenic temperature during shipping, offshore, and onshore storage. GTT has provided its NO and Mark technologies on board more than 700 LNG carriers that you can see from the outside on the left picture and from the inside on the center picture. A few years ago, we started adapting our technology to a new market, LNG as fuel. There are currently more than 60 LNG fuel ships featuring GTT technology under construction, and 17 ships are already sailing with our Mark III technology. Today's topic is dealing precisely about this, how we have adapted our technology to offer future-proof solution for a new ship type. What we see here is a successful milestone in the expansion of LNG as a marine fuel. It is a new reference on many aspects. World's biggest dual fuel vessel, biggest dual fuel engine, and biggest LNG fuel tank, alongside the biggest LNG bunker vessel. In November 2020, the CMS CGM Jacques Saadé, the first dual fuel ultra-large container vessel, loaded a full bunker of LNG from the Gas Agility chartered by Total, and it is more than 17,000 cubics of LNG, nearly 8,000 tons, transferred in about half a day, more than 5,000 TEU loaded while bunkering. The LNG autonomy is such that the ship is able to complete an 84 days round trip between Asia and Europe without refueling. And here, you can see what's inside the LNG tank of this container vessel, a very wide tank of almost 52 meter breadth. The Jacques Saadé and all our sister ships are equipped with our Mark III membrane technology, benefiting from an excellent track record at sea. Those 9 vessels built in China are now successfully operating between Europe and Asia, and some of them actually already bunkered bio-LNG. Let's have a wider look at our references and order book. So it started in September 2017 when CMS CGM confirmed adopting LNG as fuel for this 23 KTU. We are very happy to be a trusted partner for CMS CGM, who ordered a large number of additional vessels in 2019 and early 2021. Another great news was our first order in Korea with T-Span, ZIM, and Samsung. After mid-2021, we see a clear change with Korean yards turning back to membrane for new orders of containership. Even smaller size, such as the recent 7,000 to 8,000 TEU orders, equipped with smaller tank of 6,000 to 7,000 cubics. And actually, I did not include the additional container orders that we received a few days ago. But what about smaller size of tank? On another ship type, GTT received an order from VARD of the Fincantieri Group for the most advanced expedition vessel of Ponant. This first cruise project, the design pressure of the tanks has been increased to 2 bar gauge for additional flexibility. This is a solution that we can now propose for tanks of a few thousand cubics, and we will develop more this point later on this webinar. But let's see what is really making the difference. Initial ship arrangement included 2 build-up Type C tanks. Due to standard shape, they can hardly store 3,000 cubics of LNG. Membrane tanks can store 4,500 cubics and save hundreds square meter of deck on top of that you can see here. And this is what the aft tank look like when it's completed. We can see the specific tank slope, which efficiently follows the body lines for the aft tank, while the fore tank here has a pure rectangular shape. GTT Mark III Technologies allows to build LNG tanks with exotic shape to maximize the volume of LNG loaded on board. Thanks to these preferences, we are learning a lot, and we are now able to propose an efficient solution for PCTC market. So what does the PCTC market look like today? On this picture, you can see another of our references, the first bunker barge in the US, Clean Jacksonville, bunkering in February 2021, CM LNG powered PCTC equipped with Type C tank. If we look at historical car carrier order, we see that the market was very active between 2004 and 2007, and slowed down afterwards with very low number of orders between 2016 and 2020. And it is currently very active again, with close to 40 ships ordered in 2021 and already 14 in 2022. As it is stated here, the average age of the fleet is 16 years. So in the coming years, market analysts are forecasting that close to 30 ships will be ordered each year for fleet renewal, and also in order to comply with upcoming stringent regulations. Another very interesting point to notice is that PCTC market has been the first one to operate a complete switch to LNG propulsion. 98% of order book is LNG fueled, and all orders since 2021 have been ordered with LNG dual fuel engines. If we have a look at PCTC ship owners, we can see that about 40% of vehicle carriers in service are owned by Japanese companies, followed by Norway. 50% of vehicle transportation capacity is owned by 7 players, quite equally spread between them. It is not exactly the same repartition for other books that you can see here, but there is still a majority of Asian owners. Studying the main maritime routes of car carriers, we noticed that the main ports of call are in Asia, in Europe, and in North America. Considering round trip, we then estimated the endurance needed to reach these main hubs. In the end, we calculated the required LNG capacity to cover round trips between these areas. Having the possibility to perform round-trip voyages allows to save time and money, offering additional flexibility with the possibility to choose where to bunker depending on LNG price, and less bunkering operations needed. Finally, we ended up with a need for an LNG tank in the range of 2,000 to 6,000 cubics, depending on the trade. We will now make a focus on the three main trades and track the bunkering possibilities in addition to the recorded ones. Here is a trade between Asia and Europe. It is to be noted that at both ends, LNG bunker vessels are already available and able to bunker LNG fuel vessels. However, Europe has a greater number of in-service LBVs as the bunkering network started to develop earlier there. On this long trade, most of the bunkering operations occur in Northern Europe with LNG LBV Optimus, Corvallis, and Green Zeebrugge, with only track record of bunkering with Avenir Advantage in Singapore for the Asian area. For the trade between Europe and North America, some LBVs are already in service. So there is a wide choice in Europe, as we have previously mentioned, but we have also records of bunkering operations on East Coast of America. They perform bunkering to LNG fuel PCTC, such as the Clean Jacks to CM Confucius, as we saw previously, and also with the QLNG 4000. On the trade Asia to West Coast of US, LBVs are available in Asia only. There is only one, under construction on the west coast of North America, and it is in Canada. We can see that the bunkering network is under active development, yet, depending on the trade, it can be interesting to have a good endurance and a round-trip capability. Thanks to these insights, it is clear that having the flexible design and optimize the volume of the fuel tank is critical. So here come my questions to you, Jean-Guillaume. How to arrange the membrane tank and the LNG fuel system inside the PCTC, and what are the advantages of membrane technology for this application?
Thank you, John. This is a good question. If you consider an LNG fuel vessel, you have to take into account that the energy density of LNG is half the one of fuel oil. It means the LNG fuel tanks will have to be double compared with fuel tanks, which means it will interfere with some other compartments due to the increased size of it. So we decided to put it as the lowest possible in front of the engine room on cargo deck number 1, as you can see on this 3D view. And here, on this view provided by Delta Marine, you can see the overall arrangement of the membrane tank based on base LNG fuel supply. The membrane tank has a very simple box shape without any slope. It has a narrow breadth, low height to stay below main deck, and has an adaptable length. We'll come back to this a bit later. We consider a volume of 3,000 cubic meters. Also, it is designed to withstand 2 bar gauge internal pressure. The small circular dome are located on top of it at the aft end, enclosed in the tank connection space, which is not shown here. The fuel gas preparation room is located on the side of the tank, very nearby to the engine room. We worked a lot with Delta Marine on LNG fuel PCTC to come up with a relevant, sensible, and very compact solution. The membrane tank is equipped with Mark III Flex containment system. The insulation is made out of polyurethane foam and plywood, while the primary barrier is in corrugated stainless steel, and the secondary barrier is located in the middle of the insulation. In addition, the thickness of the insulation can be increased, as you can see on the left picture. The thickness of the insulation can be increased to reduce the boil-off rate, BOR. Here we want to stress that the membrane technology is scalable. First, we are aware of the pillar rows, and we understand how important they are for the hull structure of the ship. So the membrane tank is designed to fit between them. There is no impact on the pillar related to the membrane tank. The breadth of the membrane tank is simply selected according to the location of the pillar rows. Then, it is easy to modify the length of the tank in order to adapt the LNG volume in accordance with the requested endurance of the vessel. You have here an example of 2000 on the left and 5000 cubic meter on the right, where we play only with the length of the tank to fit the requested volume. So the membrane system is showing here its great modularity in both longitudinal and transversal directions. However, the LNG tank capacity has to be decided with great precaution because it will reduce the cargo capacity on the lower decks. With the help of Delta Marine, we compared the footprints of several LNG tank arrangements with the traditional fuel arrangement. We compare membrane tank with one type C and with two bilab tanks for the same LNG volume of 3000 cubic meters. Membrane on the left, one type C in the middle, and two bilab on the right. Despite all LNG tanks will take on cargo space, we found out that membrane tank is the most compact and save up to 100 CEU compared with type C solution. Now let's have a look on how and when the LNG is consumed and how the boil-off gas is managed. First, at sea, on the left of your screen. The main engine has a consumption greater than the natural boil-off. So the boil-off is fed to the main engine through the HP compressor. In the meantime, some liquid is pumped from the LNG tank and supplied to the main engine. If the PTO is running, the auxiliaries are not working, which means there is no gas consumption as the auxiliaries. Then, at port, in operation, on the top right of your screen, the auxiliaries are running and their consumption correspond to the natural boil-off gas. So this boil-off gas is fed to the auxiliaries through the low-pressure compressor. Last but not least, when idle, there is no gas consumption at main engine and only a small one for the auxiliaries for the hotel load. In this case, the pressure will slowly rise inside the LNG tank, but it can be managed by pressure accumulation within the two-bar gauge design pressure. To conclude this design section, we recently received an IAP from DNV for our work on LNG fuel PCTC equipped with membrane tank. You can see on the left the scope that was submitted, and in the middle the picture of the ceremony that took place at North Shipping exhibition earlier this year. Let's move to a new development we applied to this PCTC. Recently, we have developed circular domes applicable to LNG fuel vessels. They are smaller than the large rectangular ones used on LNG carrier, and they take less time to install at new building stage. They are also lower, and they have been developed to be applied to membrane tank able to reach two-bar gauge. So they fit really well on this PCTC. Talking about two-bar gauge design concept, the idea was to offer the maximum autonomy and flexibility. This was first achieved thanks to an alternative design process run between Ponant, the Bureau Veritas, and the French flag. The two-bar gauge tank allows to increase the holding time, as you can see on the left side graph, where the red curve shows the holding time in an atmospheric pressure tank, and the blue curve in a 2-bar gauge tank. You can also see that the holding time will vary with the tank filling level, and GTT is experienced in calculation to assess this holding time for membrane tanks. It also allows for to bunker warmer LNG, thus offering more flexibility in the quality of LNG bunker. We are also confident that the 2-bar gauge design pressure is sufficient to meet all operational needs. This 2-bar gauge tank concept was then extensively validated by 3 major classes through AIPs. On the right side, you can see Commander Charcot from Ponant, who benefited first from this innovation. This polar cruise expedition vessel has been delivered in 2021 and is currently sailing close to the North Pole. Taking into account the will of the maritime industry, we are supporting the path to decarbonization by working on NH3 or ammonia compatibility for membrane tank. So let's have a look at NH3 readiness for a membrane tank solution. We know already that not any modification of the primary barrier will be needed. And thanks to its narrow breadth, the tank shape would be already suitable for ammonia sloshing loads, which are higher than LNG sloshing loads. Then some adaptation would be needed on the inner hull to cope with higher loads and low temperature. In addition, we have already worked and we are still working with several major classification society on ammonia-ready notation, mostly for container carriers. Let's continue with a few words about our industrial schemes and partners. On this map, you can see a mix of GTT licensed shipyard and outfitters with the main PCTC designer and current builders. In gray are the ship designer experienced with PCTC, we have already worked with on PCTC. In dark blue are GTT licensed shipyard. Some of them have experience in PCTC. They are the one with the underlined name, such as Hyundai Mipo, Jianan, or Imabari. In light blue are PCTC experience yard, but many of them do not know membrane installation. So we have added in dark blue box the GTT qualified membrane outfitters able to support the PCTC building yard with membrane installation. How to build an LNG membrane tank? There are several alternatives. On the left side, the picture shows the exhaust skeleton solution with a 6,500 cubic meter membrane tank was lifted on board 15K TEU Apaglass retrofitted vessel in November 2020. Despite it showed GTT has great ability to manage complex projects until completion, we do not foresee any application for this exhaust skeleton for PCTC, mostly due to the shape and location of the LNG tank in these vessels. At the bottom left, you can see the LNG brick alternative, which is also another exoskeleton solution. It could be applicable for PCTC up to around 3,000 cubic meters. In the middle, there is the usual in-situ membrane installation, same as for large LNG carrier, where the containment system is outfitted at yard premises when the tanker is completed. If the shipyard has experience with membrane installation, it can be done by its workers. If he is a newcomer about membrane installation, it can be supported by a GTT qualified outfitter company that will install membrane on behalf of yard. On the right side, the last alternative is the LNG block for larger capacity, where the hull blocks are assembled together to make the hull of the tank, and the containment system is then fitted inside the hull. This alternative was successfully been applied for 18K cubic meter LNG tank for CMS CGM ultra-large container vessel. The most suitable industrial scheme for PCTC are either LNG brick or LNG block, depending on the size of the LNG tank and shipyard preference. That's all for this section. So back to you, John.
Thank you, Jean-Guillaume, for sharing all these valuable insights. Now it is time to conclude the first part of our webinar. And here is a recap of the main messages. Our marine tank enables to save an important number of CEUs compared to Type C solution and allows to increase the autonomy of the vessel. Thanks to this simple arrangement, the impact on the vessel design is limited. And with the recent development validated in GTT and applied on LNG fuel ship projects, the membrane tank solution offers a flexible design with 2 bar gauge maximum pressure and future-proof design with ammonia-ready notation. To conclude, you can get the most flexible and future-proof PCTC with GTT membrane tank. We have now finished our presentation. We will start the poll, which we will comment at the end of the session. Take a few seconds to answer before we start the Q&A. And remember that you can write down your questions in the dedicated Q&A box. We will be happy to answer any question. So if you are interested in more details, you can, of course, contact us. You can find here our email address and or join your contact reference you may have in GTT. We will answer all the received questions, and if we don't have enough time, we will answer by email. So now starting the poll. Okay, so we will start the Q&A session. So I can see that we are receiving currently quite a lot of questions. First one is related to safety. So what about safety aspects of membrane solution? PJ, if you want to answer this one.
But safety aspect for membrane solution. Let's start with main reply is that membrane tank is designed in compliance with IGF code and other relevant regulation, which means it is equipped with all safety features requested, such as the pressure relief valve, venting mask, ventilation when needed, pressure and temperature sensor, etc. And it is fully compliant with this regulation. Also, membrane tank is fully enclosed in a double bulkhead or cofferdam, covered with fire insulation. So it is a lot of segregation, while Type C tank only have a single bulkhead enclosure. And then The fire risk has been extensively studied during design development, and we succeeded to meet the classification society satisfaction by receiving this approval in principle IIP.
Okay, thank you. I see that we have several questions dealing with the same topic related to sloshing. So one is said, how does GTT consider the sloshing matter for LNG fuel tanks, which is more serious than cargo tanks? So I expect that it is related to usual LNGC. And yeah, another person asking, what about sloshing?
Yeah, as far as sloshing is concerned for this PCTC, it is quite different with LNG carriers, but we have strong advantages here, despite that we need to consider all filling ratios for this LNG fuel tank, which is different from LNG carrier, which the filling ratio are limited. But we have a strong advantage here is that the LNG tank has a narrow breadth, as you were able to see in the presentation. The breadth is keeping stay between the PRO, so it is quite narrow compared to LNG carriers. So it is of great help to limit the amount of sloshing impact and so the sloshing loads in this fuel tank. And also it is smaller, the capacity, general capacity is around 3,000 cubic meters or 5,000 cubic meters. So very reduced capacity, very reduced breadth. So great advantage for us for sloshing loads.
Okay, I think this covers quite well the topic. Thanks. Okay, another one. Oh, we have quite a lot of technical questions. So maybe one regarding process. Have you ever experienced any vessel with HP compressor to consume BOR to ME-GI engine in your past project?
I am quite sure that it happens on LNG carriers because MEGI engine and HP compressor are were quite used and are still in service for LNG carriers. So definitely it has happened on LNG carrier. For PCTC, of course, not applied so far with membrane tank. For the rest of the market, I'm not sure. I don't have all the information related to the market, so I cannot say. Yeah, really, John?
Yeah, maybe if I can complete, I will come back to our references with a container vessel. You can see that quite all the recent orders for container vessel are with a ME-GI engine from MAN. Actually, all of them except to the one for PIL recently. So yeah, all of them are with a ME-GI engine, and also the one from Hapag-Lloyd, which was retrofitted and is now sailing with the pictures that we saw with the exoskeleton tank lifted and installed at the retrofit yard in HRDD. So yeah, this is already something that is applied also for LFS. Coming back to the Q&A slide. Okay, so I see that we have some questions on the the volume constraint and the pressure. So though we are mainly volume constrained, could you comment on the tank weight? So for example, relative weight to fuel, function of pressure rating, perhaps. Thank
you. Okay, so to answer this question, let's take a hypothesis of the size of the tank. So basically, let's consider a 3,000 cubic meter membrane tank. Including the 2 bar gauges and pressure. So we perform a study with this kind of tank with the shape I showed previously. And we estimated that the weight of the structure is more or less in the range of 700 tons added, included in a and the containment system. And it is all inclusive. I mean, there is already the 2 bar gauge pressure design taken into account in this value. So then you can make a function of it depending then on the size of the tank that you will need in the end. But then it will go into more detailed calculation and stuff. But that is basically the around 700, 800 tons of hull to withstand this 2 bar gauge pressure for the requested volume of 3,000 cubic meter.
Okay, good, thanks. So another one on the industrial scheme and the impact on the design. So someone asking, in order to save CEU, do you think LNG brick is the best solution for PCTC rather than LNG block?
In fact, the saving of CEU is not related to LNG brick or LNG block solutions. The saving of CEU is applying a membrane tank or any competitor with a Type C tank solution. What we say is basically when you apply membrane tank, because it's very compact and square shape, it saves CEU whatever the LNG brick or LNG block scheme you will select. Then when it comes to membrane tank, you can have a selection between LNG brick or LNG block. What we say is that LNG brick is for tank, LNG tank up to around 3,000 cubic meter. Because of the shape of it and the size of it, mostly I would say the length, it will start to be a bit difficult to make an LNG brick. And so most probably it will be, we would recommend to go to LNG block and assemble the whole block together and then feed the containment system in it rather than bring an LNG brick. But this can be studied because it depends on the shape, it depends on the size. So it is really project dependent, and we are open to discuss it on any real project.
Okay, good. So we have several questions now on the maximum pressure and the impact on the design. So I will try to group them. So first one is MARVs greater than 0.7 bar gauge is not allowed by the IGC code for membrane LNG tanks. Understand that GTT have obtained approval for 2 bar gauge maximum pressure in certain LNG storage tanks, especially for PCTC. And could you please clarify?
Yeah, that is true, but that's IGC code. In fact, here it is IGF code. As there is a limitation up to 700 millibar gauge, but there is also a possibility in this code to make an alternative design, which in this case you will need to submit to a classification society and flag. And it is what we did to reach this 2 bar gauge. We developed our design and then submitted to class and flag. And in fact, we did not did that in the first place for PCTC. We did that in order to move on to be able to be on board this polar expedition vessel named Commandant Charcot for Ponant. And we submitted this alternative design to BV and French flag, which we received. And this alternative design of 2 barges is still applicable for PCTC. And then we extended the validation through 3 major classes in order to have it validated and ready for PCTC application.
Yeah, and it is quite important to have this alternative design to do some work in advance. So this is the advantage that we have now, that since we have already prepared of this dossier, it will be easier for the next one.
Yeah, and we have so as I said, we have already a vessel equipped with it, sailing. It is a reference project for us, of course. So it means that it is already sea proven in operation.
Yeah. And we will come back to this later, but we will have, in fact, another webinar, especially on this project tomorrow and on Friday. We will send the link later. So, another question on the difference between Mark II barge and 0.7 is any difference on the tank structure of these two designs?
Sorry, can you repeat, please?
Is there any difference between tank structure between 2 bar gauge and 0.7?
Yeah, sure. There is a difference for sure. If you consider only a 700 mm gauge tank, then the tank hull will be lighter for sure, because you will have to only to manage 700 mm gauge. So the stress will be the load, not the stress. Load will be lower than with 2 bar gauge, so it is definitely lighter, sure. I don't know. I will not say here how much lower. I cannot say it precisely right now, but definitely it will be lower.
Another one on this 0.7 design. How low boiler rate is recommendable for required holding time, considering ESD, without this 2 bar gauge containment system?
In fact, with the current boiler rate we have studied in this design, it's already fit this requirement for holding time. So basically, the boiler rate is around 0.4, a bit lower than this. Then it depends if you are on Mark III or Mark III Flex, but let's take roughly this value. And with this value and the study we perform, it is in line with the holding time that is requested in IGF code.
Okay, right. So still some open question. Two that are quite related regarding cost. What is estimated extra initial cost if you place a membrane tank instead of Type C? And another one, what is the cost comparison of the different solutions?
Okay, so it is a bit difficult to reply to this question because the price is not fully in our hands. What we can say is that yards are providing prices, and it depends on the industrial scheme selected for the tank construction. So we cannot directly commit to something, but what we can say is that we are competitive from 3,000 cubic meter and above. I don't know if John, if you want to add something about this.
Yeah, maybe just to add that Another one of the main difference that we have with our competitors, especially with Type C, is that they require really more metallic materials. So we are less submitted to the price of raw material prices, and with current price of metals, and especially 9% nickel price, we can see that our solution is becoming more and more competitive. So this value that you gave could be even lower currently. Okay, so I think we will just take another one and finish here, because we have already it is already quite late if we want to analyze the poll. So another one related to ammonia. What modification is needed to be done at later stage if we want to switch to LNG, or the LNG tank to ammonia?
Okay, so there are two parts in my reply. The first part is that you need to take into account as much as possible, if you know it in advance, the ammonia switch or possible switch at new building stage. So at new building stage, it is good that you are able to prepare some stuff for this ammonia switch. It is ammonia readiness. So basically, what we know is from the new building stage, we know that the tank shape should be adapted as it is for ammonia readiness, but then there is still a question related to the inner hull, to the compatibility also of the material, stuff like this. So this is the first part, the ammonia readiness at new building stage. And then, thanks to this ammonia readiness, later in the life of the vessel, you will have to contemplate and consider, study what will be needed to adapt to ammonia readiness. So it depends what you have done before a new building stage, and so what will be needed at the retrofit time. So if you have prepared a lot of things at the new building stage, there will be only few things needed at retrofit stage, and in the opposite, if you've done only few at the new building stage, there will be a lot of work to perform at retrofitting stage.
Yeah, so yeah, to conclude, it is kind of a trade-off between the initial capex that you want to invest at new building stage on the level of ammonia readiness that is requested versus the amount of investment needed at retrofit. So depending on how much you intend, or you believe that ammonia will be used at a later stage in the design.
Our recommendation about this would be to at least consider it an ammonia ready notation, or having in mind at least the ammonia readiness at new building stage, even if it's not a big work or a big notation you're targeting at new building stage. At least have it in mind to have the vessel a little bit prepared for a retrofit at later stage. It is far easier to have it retrofitted later when you have already contemplated it at new building stage.
Perfect, thank you. So I think this concludes the Q&A session. So we will now come back to the poll before ending on our webinar. So I guess that you are seeing now the results of the poll. So first question was, in your opinion, what is the main driver for the current large adoption of LNG as a fuel for PCTC? So, two main two answers are leading this one. The first one is regulation, and second one quite close. So 41%, and second one at 33% savings on fuel expense. So mainly led by regulation, and some savings also thanks to LNG. And later, or less selected by the audience, is fuel availability, and even lower the company image. Quite interesting results. Second one, what future fuel are you investigating at the moment? So here again, two questions of possibility between LNG, bio, and synthetic LNG, bio and synthetic methanol, green ammonia, and hydrogen or fuel cell. And the two one leading this for this question are LNG in first place, and second place ammonia. Quite tight results, 37% and 33%. And we can see that bio and e-methanol is starting to be more studied than before. We have actually asked this question a few months ago on another webinar, and methanol was not studied as much. And we can see that it is now studied more. Could be from recent news in the market. But good to see that LNG is still leading this this trend. Last question was about in your opinion, how long will last LNG as a fuel for PCTC? And here the audience is selecting the 10 years horizon. Second choice is 20 years. So we can see that this is something that is seen quite for long term. So almost the lifetime of the ship for 20 years. And equal between 5 years and no limit at 17% for both. Yeah, interesting results. I don't know, Jean-Guillaume, if you want to add something on this.
Yeah, just on the last reply, it's quite interesting to see that LNG is a transition fuel, so it is quietly shown here. But then when you add the bio LNG and e-LNG, this transition can last longer and can last up to the life of the vessel. So quite interesting to see these replies.
Indeed. Okay. So we have now finished our webinar for today. So if you enjoyed this one and would like to learn more about our other solutions, please register and join us for next webinars. And as you can see on this slide, it is quite a busy week for GTT regarding webinars, as we will host another one tomorrow and this Friday with Ponant and Gazum, during which we will share some valuable insights on LNG bunkering, focusing especially on feedback of the Commodore Charcot being bunkered by Gazum bunker vessels. It is now time to end this webinar. Many thanks for attending. Have a good day or good evening, depending on where you are, and see you next time. Bye.
Thank you very much. Bye-bye.